Hi, my name is NISHA SYUKRI, DE190115. So today I'm going to explain about our group's assignment. On 21st August of 2013, an express bus rammed into a divider and plunged into a 60-meter ravine near Genting Highlands. 37 people were killed and making it the country's worst road tragedy. So it was said that the bus was not controlled well and believed that the bus was drove over the speed limit of 50 km. It was also recorded that the speed of bus by that time was 61.2 km per hour before it collided with the wall. Other than it was resulted by the speed of the bus, it was also said that it was also overcrowded with a capacity of 44 passengers. One of the factors that would cause bus accidents is speeding or not following the recommended speed limit of heavy vehicles by the authorities. And based on the problem, we will provide a solution on the suitable speed for heavy vehicles on road, specifically on the hillside, because most accidents happen there. Through these assignments, students be able to understand why is speed limit very important and need to be practiced by every driver for each other's safety. A suitable speed that would fit a bus weight according to the passenger amount of passenger in the bus is needed to make sure that all the bus drivers obey the rules. The situation of a school bus on a hill is illustrated as the figure. So using the formula of momentum, we will calculate the speed limit of the bus. So the objective of this project are to help bus driver identify the minimum speed they could use during driving on the road, to find a suitable speed of buses according to the total weight of the passengers in the bus, including the bus weight, and third is to use technologies such as Excel to solve the numerical equation in order to determine the speed and momentum of the bus. When it is moving, the mass and velocity of the bus needed to be considered. Therefore, bisection, second, and Newton-Raphson numerical method are the best method to find the roots of the equation. So the equation is obtained from the same source. Thus, this assignment will apply this numerical method to calculate the depth manually and also by using Excel to get more accurate result. The equation of calculation shown at the problem statement and this flowchart is to make sure that this assignment can reach the objective by the end of the day. So here we can see that first we will start by conducting manual calculation, and once the result is obtained, we will see whether the result is tally with what we're looking for, and if it is, then we will compare the manual calculation with the maple calculation. If the result is correct, then the analysis result and discuss the difference between manual calculation and software calculation. After that, we will proceed with report writing and complete the report and also the video of assignment.
Assalamualaikum and hi, my name is Khuzaimah Rabiah binti MAHAMAD KHARIOL NIZAR. My matric number is DE190155. Okay, today I will explain about manual calculation and our simulation. For firstly, we got the equation negative 9.81 over 4x squared multiplied with exponent x plus sine x minus 0.017. Then with the aid of Desmos calculator online, we found this graph. This is the shape of the graph. Therefore, we determine the roots of intervals. We got two roots, which is the one is negative 4 until negative 2. This is used for bisection method since the graph cross x-axis is at negative 3. And the second roots of intervals is negative 3 until negative 1. For the first method, which is bisection method, we are using the roots of interval negative 4 and also negative 2. C is the midpoint between A and B value. We substitute the value of A, B, and C into the function of FA, FC, and also FB. There are two conditions, which is the first one, if FA multiplied with FC, the value is less than 0, then we need to move the value of A at the bottom, and also the C value move to the B. The second condition, where FA multiply with FC and we got the value is greater than 0, then we need to move the value of B at the bottom layer of it and we move the C value at A. We iterate it until it fulfill our condition, which is it is less than 0.0005. Then we got the answer at C is negative 3.0293. Dissection method, we are using the same way as the manual calculation, but for the midpoint, we are using the formula, which is L3 plus N3 and divide with 2. Then we got the answer of C, which is 3. And we just substitute the value of A, C, B into the function, and we're using the formula of this, which is we substitute it, and I'm using the function of fill it, the software, then it will automatically fill in the value. I repeat the process until it reach the condition, which is 0.003, and I got the same answer as the manual. Move to the second method. We choose the roots of interval is -3 and -1. Then we label it the A and B, and we find the function of omega I as the usual by substitute the value of omega I into the function, and we got the answer, and we label it as a C and D. In order to find the new value of omega I plus 1, we are using the formula of A multiply with D minus with B multiply with C and divide with D minus C. Then we iterate it until it reaches the value of less than 0.0005. We got the answer as negative 3.0293. We are using the root of interval -3 and -1. -3 we fill at omega 0, and also -1 we fill at omega 1. In order to find the function of omega, we just substitute the value of omega into the equation. In this case, we are substitute the value of C3, which is the value is -3. Then we got the answer. In order to find the value of omega I plus 1, we are using the formula, which is the C3 multiply with D4 minus with C4 multiply with D3 and divide D4 minus D3. Then we got the answer. We iterate it until less than 0.005. We got the answer -3.0293. The third method, or the Newton method, we are choosing only one root of interval. In this case, we are choosing -3, and we label it as A, and the function of omega I, we label it as B, and the differentiation of the function of omega I, and we label it as C. In order to find the new omega I, which is omega I plus 1, the formula we are using is A minus B divided with C. Then we got the new value of A, and we repeat the same process until we reach our iteration condition, and we got the answer, which is -3.0294. It is proven that even though we are using the different method, but the answer is still the same, which is approximately -3.0293. Okay, moving to the third method, which is Newton method. We are only choosing one root of interval. In this case, we are choosing -3 as the root of interval. We fill in at the omega naught here, and in order to find the function of omega I, just same like before, like another method, we just substitute the value of omega naught. And in order to find the differentiation of omega naught, we just differentiate the equation, and we just fill in the value. To find the value of omega I plus 1, we are using the formula G3 minus with H3 divide with L3. Then we got the answer. The answer will be at here, omega I plus 1. And same like the above, we just substitute. In this case, we are using the fill function.
Hi, my name is TAMIN, and I will explain about the findings for our results. So, through the obtained result, it can be concluded that the suitable speed of buses according to the total weight of the passengers in the bus, including the bus weight, is 54 km per hour, and the same results are obtained by using the manual calculation. So, why I will look at these kind of results is because different kind of methods are used to obtain the result, which is by using manual calculation and also Microsoft Excel. There are three types of methods that are used to identify its output's validity, which are bisection method, second method, and Newton method. And for the root obtained, which is omega, the value obtained is -3.0293. And when the omega is substituted into the function of omega, a result of -0.015 will be obtained. And then the value of velocity, which is 0.017 km per second, will be subtracted with 0.015, which resulted for the value of 0.002 km per second. So the value is then converted from km per second to km per hour, and the result is 7.2 km per hour. It is obtained through those calculation given. And why we get these findings? As for the root omega, which is calculated using the bisection method, it is convergence guaranteed. And for second method, it converges more quickly than a linear rate, making it more rapidly convergent than the bisection method. And it approximates the function value at integral edges. So, but nevertheless, those three methods still yield the same results. So, last but not least, the outcome was attained successfully, and the speed of the bus that must be utilized to guarantee the safety is 54 km per hour. Additionally, Microsoft Excel is utilized to perform equations and ensure the results are consistent with the manual computations. Therefore, the manual calculation is valid as all of the approaches tested also yielded the same outcome. Finally, the result was achieved quickly and accurately by using Microsoft Excel, and it benefited the bus driver to being more cautious when driving the bus so that it will not exceed speed limit while driving on the road. And that's all. Thank you.